Implicit differentiation. Okay, so we've dealt a lot with functions. Um, and you know, we've dealt with equations with x's and y's, both explicit and implicit, probably. But explicit means that y is isolated on one side of the equation. And we can tell if that's a function or not very easily. In other words, if you had this equation and you plugged in an x value, you're only getting one y back, so that's a function. But if you saw this plus or minus, you would know that for every x value, you're getting a positive and a negative answer, so it's not a function. Implicit equations are very different. Typically, we don't have y isolated on one side. There could be powers of y, and both x's and y's appear throughout. For example, x squared plus y squared minus 2x plus 4y plus 16 equals 0 is a circle. We can even take the derivative of that, believe it or not. To do this, we're not going to be using f of x because we're not using function notation. So instead of finding f prime, we're going to be using the notation dy dx, which this is an alternate way to say the derivative, and it specifically means the derivative of y with respect to x. That's what it means. So as we're going through this, we've got two different men that really founded calculus, and their notations are both used backwards and forwards. So we can see this a lot, and we'll get used to it. So we're going to use dy dx a lot today. So here's an explicit function, and so we're going to find the derivative of that. So let's start by rewriting it where it's a little bit easier to take the derivative of. That would be y equals 25 minus x squared to the 1/2 power. The derivative of y with respect to x would be 1/2 25 minus x squared to the negative 1/2 times the derivative of the inside, which would be negative 2x. Now for our purposes here, I'm going to clean that up a little bit. And that's a 1/2. Negative exponent means it's 1 over, and that's really the square root of 25 minus x squared. And then we have times negative 2x, which would be negative 2x over 1. The 2's would divide out, and I would be left with negative x over the square root of 25 minus x squared. Now let's compare that to doing what is called implicit differentiation. So in this one, we're leaving it as x squared plus y squared equals 25. So when I take the derivative of x squared, that's going to be 2x. Now technically, we are taking the derivative of x with respect to x. Y squared would be 2y, the derivative of y with respect to x, and then the derivative of 25 is 0. Now when we've been taking the derivative when there's x's, we don't write dx dx because technically it just goes away. So I'm left with 2x plus 2y dy dx. Now we're trying to find dy dx, so we're going to solve for it, which means I need to subtract the 2x and then divide by the 2i. Now notice that the 2's are going to cancel, and I'm left with negative x over y. When you say, well, over here I got negative x over the square root of 25 minus x squared. So these aren't the same, are they? Remember here, y is the square root of 25 minus x squared. So we really did get the same answer. But our derivative, in this case, we can do it if we know points on the graph. We know an x and a y. Makes it a little bit easier on the calculations, actually. So we're going to use the graph of a circle. Now, this circle has a center here and a radius of 1, 2, 3, 4, 5. So let's remember real quick how to find the equation of a circle. It's x minus h squared plus y minus k squared equals r squared. And hk is the center. And r is the radius. So this would be, the center is 3, negative 2. So it'd be x minus 3 squared plus y minus a negative 2 squared equals the radius, which was 5, squared, which would be 25. So I'm going to multiply this out so we can actually have a easier formula to deal with. So x minus 3 squared is going to be x squared minus 6x plus 9. If I multiply this out, it's y squared plus 4y plus 4. And then let's just kind of put them all in order. X squared plus y squared, put our squared terms first, then minus 6x and a plus 4y. And then I have a plus 13 equals 25. Or I can write that as, let's see, if I subtract 13, I'd have 12 on the other side. That's considered the standard form for the circle. This would be the center form. This is the standard form. So let's take the derivative. This would be 2x, technically a dx, but I don't need to write that. And then 2y dy dx minus 6 dx, don't need to write it, 4 dy dx, because we took the derivative of y, equals the derivative of 12, which is 0. Now notice we have two terms that have dy dx. This one right here and this one right here. I want to leave those on the left side, and I'm going to move everything else to the other side. So I'm going to keep 2y dy dx minus, oh whoops, it's a plus 4 dy dx. And when I move the 2x and the negative 6 to the other side, that's going to turn into a, well, I'll do that as a negative 2x plus 6. Okay. Now each of these terms have a dy dx. So I'm going to factor it out. If I factor out dy dx from that term, I'll have 2y. Factor it from this term, and I have plus 4. Now, as ugly as that looks, it's just an expression being multiplied to dy dx. So I can divide both sides by that expression. And we have an expression for dy dx. Now, I'm noticing they're all even, right? So I could factor out a 2 from the numerator, and that would be negative x plus 3. If I factor out a 2 from the denominator, I'd have y plus 2. And the reason I'm doing that is so I could divide out the 2's. I could even rewrite this as 3 minus x. That might even look prettier. So I got 3 minus x over y plus 2. And you're thinking to yourself, Miss Zimbritsky, you're crazy. That's not simpler. But it will be. So we have a table of points around the graph. And we're going to plug the points in to find the slope at any point around the graph. So we're going to start with 0, 2. So the slope at 0, 2, the 0 is going to go in for x, so 3 minus 0 over the y value plus 2. So I get 3 over 4. So if I go to my graph, at 0, 2, which is right here, it's saying that the slope at that point is up 3 over 4. 3 over 4. So I get this line. Oh, that's not a straight line. Right there. And that is tangent. How nifty. Okay, what about 3, 3? I'm going to do this in a different color. So dy dx equals 3 minus the x value. And then it's y plus 2. So the y value plus 2 gives me 0 over 5, which is just 0. Okay, so at 3, 3, it says there's a slope of 0. So 3, 3. Ah, that is tangent right there. 8, negative 2. So the slope at that point is going to be 3 minus the x value over the y value plus 2. So that's negative 5 over 0. Ooh, that's undefined. Wonder where that point is. So 8, negative 2. 8, negative 2. Well, that just makes sense. This is going to be an undefined slope. It's going to be a vertical tangent line. So next, I've got 3, negative 7. Three minus 3 over negative 7 plus 2. Hey, that's another 0. So 3, negative 7. Oh, that's that other point there. Slope is 0. Let's get a different color. 6, 2 is the next one on our list. dy dx. This one doesn't want to write. Technical difficulties. Get another pen. dy dx. 3 minus the x value over the y value plus 2. Negative 3 over 4. So let's see where that point is. 6, 2. Oh, does it make sense that that's a negative slope? Well, yeah. 3 over 4. Up 3, back 4. If I connect those dots. Oh, great straight line there. Yeah, that's the tangent line. And so forth. So this formula can find the slope at any point all the way around that graph. So let's try it on a few of these. Now remember, you can pause the video, try them, and then look back to see if you got them right. So the first one. y squared is going to be 2y dy dx. This is going to be 2, technically dx dx, then 3 dy dx. I want to group all of my dy's, dx's, so I need to subtract that one. Both of those have a dy dx in them, so I'm going to factor it out. That leaves me with 2y minus 3 equals 2. So dy dx equals 2 over 2y minus 3. The derivative of 2x, if we're with respect to x, is just a 2. ey would be e to the y, but then we need to take the derivative of y, which would just be a 1 dy dx. This would be 2x, technically dx dx, minus 2y dy dx. All right, let's clean that up. That's just ey, e to the y, dy dx. Need to move that to the right side. So 2x is still on the right side, and I want to move that 2 over to that side, so minus 2. Factor out the dy dx, and you get e to the y plus 2y equals 2x minus 2. Divide both sides by that expression. Easy peasy. Oh no, 2xy? Gosh, that looks like we have a product. Okay, so we have a product there. So we need to take the derivative of the first, which is a 2, times the second, plus the first, times the derivative of the second. So the derivative of y would just be 1 dy dx equals 6y. We took derivative of a different variable, so dy dx, then plus 2. We took with respect to x, so that's good. That's really just 2x dy dx. This needs to be moved over, so minus 6y dy dx equals 2, and move that back to the right, minus 2y. Factor out dy dx. Then divide by that expression. Ooh, there's a lot of 2's, aren't there? A lot of even numbers. So we could simplify it even further by dividing the numerator and the denominator by the same number, which would give me 1 minus y over x minus 3y. Five x cubed plus 3. So let's see, that's going to be 15x squared, and we took the derivative with respect to x, so that's fine. 3 is gone, equals 2 dy dx. Oh no, it's another product. So that's the first, that's the second. So the derivative of the first is going to be minus 6x times the y plus the first times the derivative of the second, which is 1 dy dx. Now, the dy dx's are all on this side, so maybe I should start moving some stuff to the other side. So I'm going to add the 6xy to the left side. That's going to be minus 3x squared dy dx. And I can factor the dy dx out from that side. So if I factor out dy dx, I'm going to have 2 minus 3x squared. Whoops. That's a times. Gosh, I'm tired. Divide by that expression. Equals dy dx. A couple more examples. For what values of x will this curve have a horizontal tangent? Ooh. So horizontal tangent means what? This means that dy dx is 0. Okay, so we need to take the derivative. 3x squared plus 3y squared dy dx equals, okay, so that's a product. So the derivative of the first is going to be 4 times the second plus the first times the derivative of the second, which is going to be the derivative of y, is dy dx. And the derivative of 1 is gone. Let's group the dy dx's over here. And then I'd have 4y minus 3x squared. Factor out the dy dx. And then divide. So for this to equal 0, the numerator would have to equal 0. So when would this equal 0? So when y equals 3/4 x squared. Ooh, you say. Yeah, ooh is right. How can I solve that? I only have one equation. Oh, no, I don't. I have 2 equations. We still have this equation. So I have an expression for y. I can use substitution. This would be 3 cubed is 27, 4 cubed is 64, and that's x to the 2 times 3 is 6. 4 times 3/4 is 3, x cubed plus 1. Now there's 2 ways to solve this, to be honest. We could get everything on one side, set it equal to 0, and figure out where the function equals 0. And if I had a calculator, I could show you. So pause that. We'll show that in class tomorrow. because I can't believe that. That didn't work out very well. So we'll finish these in class.